SER cable, standing for Service Entrance Cable, is indeed rated for outdoor use. The abbreviation SE itself indicates that the cable is designed and approved for applications where it will be exposed to the elements. This includes direct sunlight, rain, snow, and temperature fluctuations. Its primary purpose, as its name suggests, is to bring electrical power from the utility company's distribution point, often a pole or underground transformer, to the main electrical panel inside a building. This connection is crucial for establishing the electrical service for the entire structure. The construction of SER cable is specifically engineered to withstand these environmental factors. It typically consists of multiple insulated conductors, often made of copper or aluminum, bundled together and wrapped with a protective outer jacket. This jacket is usually made of a material that is resistant to moisture, abrasion, and ultraviolet radiation, all of which are common challenges in outdoor environments. While SER cable is primarily intended for service entrance applications, its robust construction also makes it suitable for other outdoor uses. This may include wiring for detached garages, sheds, or other outbuildings, as well as for outdoor lighting systems. When using SER cable outdoors, it is important to adhere to all applicable electrical codes and regulations, such as those outlined in the National Electrical Code, or NEC. This includes proper installation techniques, such as using appropriate fittings and connectors, providing adequate support and protection for the cable, and ensuring that the cable is properly grounded. Failure to follow these guidelines can result in electrical hazards, such as shocks, fires, or equipment damage. Furthermore, it is crucial to select the correct size and type of SER cable for the intended application. This depends on the amount of electrical current that the cable will be carrying, the distance of the run, and the environmental conditions. Consulting with a qualified electrician is always recommended to ensure that the correct cable is selected and installed safely and correctly. When installing SER cable outdoors, several precautions must be taken to ensure safety and longevity. Firstly, the cable should be protected from physical damage, such as being run over by vehicles or being exposed to sharp objects. This can be achieved by burying the cable underground in a conduit, or by running it along the side of a building or other structure. Secondly, the cable should be properly supported to prevent it from sagging or straining. This can be done by using cable ties, straps, or other support devices. Thirdly, the cable should be protected from moisture. This can be achieved by using waterproof connectors and fittings, and by ensuring that the cable is properly sealed where it enters or exits buildings or equipment. Fourthly, the cable should be properly grounded to prevent electrical shocks. This can be achieved by connecting the cable's grounding conductor to a grounding electrode, such as a ground rod or a water pipe. The size of the grounding conductor should be selected based on the size of the circuit conductors, as specified in the NEC. Fifthly, the cable should be installed in accordance with all applicable electrical codes and regulations. This includes the NEC, as well as any local or state codes. It is important to consult with a qualified electrician to ensure that the installation is done correctly and safely. In addition to these precautions, there are also some specific considerations for different types of outdoor installations. For example, when installing SER cable underground, it is important to bury the cable at the correct depth, as specified in the NEC. This depth varies depending on the type of cable and the location, but it is typically at least 18 inches. It is also important to protect the cable from damage from rocks or other sharp objects by burying it in a bed of sand or gravel. When installing SER cable on the side of a building, it is important to use the correct type of fasteners to secure the cable to the building. The fasteners should be made of a material that is resistant to corrosion, such as stainless steel or galvanized steel. It is also important to space the fasteners correctly to prevent the cable from sagging. When installing SER cable in a wet location, such as near a swimming pool or a fountain, it is important to use special precautions to prevent electrical shocks. This may include using ground fault circuit interrupters, or GFCIs, to protect the circuits, and by using waterproof enclosures for all electrical equipment. Finally, it is important to inspect SER cable regularly for signs of damage. This includes cracks, cuts, or abrasions in the outer jacket, as well as loose or corroded connections. If any damage is found, the cable should be repaired or replaced immediately. In summary, SER cable is a versatile and reliable wiring solution for outdoor applications. Its durability, weather resistance, and compliance with electrical codes make it a safe and effective choice for service entrances, outdoor lighting, and other exposed wiring needs. Remember to always consult with a qualified electrician to ensure proper installation and adherence to all safety regulations. SER cable, being designed for outdoor use, is constructed with materials that can withstand the elements. The outer jacket is typically made of a sunlight-resistant, moisture-resistant, and flame-retardant material. This protects the conductors inside from damage due to ultraviolet radiation, water ingress, and potential fire hazards. The conductors themselves are usually made of copper or aluminum, and they are insulated with a thermoplastic or thermoset material that is rated for the specific voltage and temperature requirements of the application. The NEC provides detailed guidelines for the installation of SER cable, including requirements for support, protection, and grounding. These requirements are intended to ensure that the cable is installed safely and reliably, and that it will continue to perform properly over its lifespan. It is important to consult the NEC and any local codes to ensure that all installations are compliant. When selecting SER cable for a specific application, it is important to consider the ampacity of the cable. Ampacity is the maximum amount of current that the cable can safely carry. The ampacity of a cable is determined by its size, the type of conductor material, and the insulation temperature rating. The NEC provides tables that list the ampacity of various types of cables under different conditions. It is important to select a cable with an ampacity that is sufficient for the load that it will be serving. It is also important to consider the voltage drop of the cable. Voltage drop is the amount of voltage that is lost as electricity flows through the cable. Voltage drop can be a problem in long runs of cable, as it can reduce the voltage available at the load. The NEC provides guidelines for calculating voltage drop and for selecting cable sizes that will minimize voltage drop. In addition to the NEC, there may be other codes or regulations that apply to the installation of SER cable. For example, local building codes may have specific requirements for the type of cable that can be used in certain applications. It is important to consult with local authorities to ensure that all installations are compliant with all applicable codes and regulations. Finally, it is important to remember that electrical work can be dangerous. It is always best to consult with a qualified electrician before attempting any electrical work. A qualified electrician will have the knowledge and experience to ensure that the work is done safely and correctly. While SER cable is rated for outdoor use, it is important to understand that it is not designed to be directly buried in the ground. If you need to run a cable underground, you should use a cable that is specifically designed for direct burial, such as underground feeder or UF cable. UF cable has a solid plastic jacket that provides additional protection against moisture and physical damage. When installing SER cable outdoors, it is important to use the correct type of fittings and connectors. These fittings and connectors should be rated for outdoor use and should be designed to protect the cable from moisture and corrosion. It is also important to make sure that all connections are tight and secure. Loose connections can cause overheating and can lead to electrical fires. One common application for SER cable is to connect a detached garage or shed to the main electrical panel in the house. When doing this, it is important to follow all applicable codes and regulations. This may include running the cable through a conduit, providing a separate grounding electrode at the garage or shed, and installing a disconnect switch at the garage or shed. Another common application for SER cable is to provide power to outdoor lighting. When doing this, it is important to use fixtures that are rated for outdoor use and to protect the wiring from the elements. This may include using weatherproof boxes and fittings, and running the wiring through a conduit. It is also important to install a ground fault circuit interrupter, or GFCI, to protect the circuit. GFCIs are designed to detect small leaks of current to ground and to quickly shut off the power to the circuit. This can help to prevent electrical shocks. In addition to its use in residential applications, SCR cable is also used in some commercial and industrial applications. For example, it may be used to provide power to outdoor equipment such as air conditioners or pumps. When using SCR cable in commercial or industrial applications, it is important to follow all applicable codes and regulations. This may include using heavier gauge cable, providing additional overcurrent protection, and installing additional grounding electrodes. In conclusion, SCR cable is a versatile and reliable wiring solution for outdoor applications. Its durability, weather resistance, and compliance with electrical codes make it a safe and effective choice for service entrances, outdoor lighting, and other exposed wiring needs. Remember to always consult with a qualified electrician to ensure proper installation and adherence to all safety regulations. Always disconnect power before working on any electrical circuit. Double check that the circuit is not energized with an appropriate meter, and follow lockout-tagout procedure. When working with electricity, personal protective equipment must be used, including safety glasses, gloves, and appropriate footwear. When unsure about any part of the electrical work, it is best to consult with a qualified electrician. SCR cable must be supported properly. Support should be no more than 30 inches apart when installed horizontally, and no more than 15 inches apart when installed vertically. Use appropriate cable staples or cable ties that are rated for outdoor use. Be careful not to damage the cable when securing it. Never pull the SCR cable too tightly. Leave some slack to allow for expansion and contraction due to temperature changes. When passing SCR cable through a wall, use a cable bushing or grommet to protect the cable from abrasion. Seal the opening around the cable with caulk to prevent water from entering the wall. When connecting SCR cable to a junction box or equipment enclosure, use a connector that is listed for use with SCR cable. Make sure the connector is properly tightened to provide a secure connection and to prevent water from entering the enclosure. Never splice SCR cable in an open location. Splices must be made inside a junction box or enclosure. Use wire connectors that are listed for use with the size and type of conductors being spliced. SCR cable is often used for subpanels. Make sure that the subpanel is properly grounded. Run a separate grounding conductor from the main panel to the subpanel. Do not use the neutral conductor as a grounding conductor. When connecting a SCR cable to a breaker, make sure the breaker is sized appropriately for the circuit. The breaker should protect the cable from overload. Never use a breaker that is larger than the ampacity of the cable. Check the voltage of the circuit before connecting any equipment. Make sure the equipment is rated for the voltage of the circuit. If the equipment is not rated for the voltage of the circuit, it could be damaged. It is also crucial to ensure proper overcurrent protection, typically in the form of circuit breakers or fuses, are installed to protect the SCR cable from overloads and short circuits. The size of the overcurrent protection device should be matched to the ampacity of the cable, as specified in the NEC. Overcurrent protection devices must interrupt the flow of electricity to protect the SCR cable and prevent overheating. Always follow the manufacturer's instructions for installing and terminating SCR cable. These instructions provide specific guidance on how to properly strip the cable, connect the conductors, and secure the connections. Ignoring the manufacturer's instructions can lead to improper installation, which can compromise the safety and performance of the electrical system. SCR cable is permitted for use in wet locations. However, special precautions must be taken to prevent water from entering the cable and causing corrosion. Use watertight fittings and connectors and seal any openings with caulk or sealant. Ensure that all equipment and enclosures are also rated for wet locations. The NEC specifies the minimum bending radius for SCR cable. This is the minimum radius to which the cable can be bent without damaging the conductors or insulation. Exceeding the minimum bending radius can weaken the cable and reduce its lifespan. Refer to the NEC for the specific bending radius requirements for different sizes and types of SCR cable. When installing SCR cable in an area where it is subject to physical damage, such as near a driveway or walkway, it is necessary to provide additional protection. This can be achieved by installing the cable in a conduit or by using a cable tray. The conduit or cable tray will protect the cable from impact and abrasion. If SCR cable is being installed in a corrosive environment, such as near the ocean or in an industrial area, special precautions must be taken to prevent corrosion. Use corrosion-resistant fittings and connectors and coat the cable with a corrosion-inhibiting compound. Regularly inspect the cable for signs of corrosion and replace it if necessary.